Day 3.2 Homework Solutions. Before we look at our actual homework questions, let's look at this little illustration. So we've got Yaman. He's in big trouble. He was allowed to go out on Saturday, but his parents told him they needed to know exactly where he was going to be. The next day, he told his dad that he was on Macdonald. Later that day, he told his mom that he was on George Street. And then later, when his parents compared stories, they were not pleased. How does our young hero stay out of trouble without lying to his parents? So, our first statement here, where he told his dad he was on Macdonald, can be illustrated by this red line right here going along Macdonald. Okay? So we don't know where he is specifically on Macdonald, but we know that he's somewhere on this street. Now, he tells his mom that he's going to be on George Street. So we'll draw this little green arrow, this green line, marking all the possible places that he could be according to his mother. So the question is Yaman in trouble? Did he lie to his mom? Did he lie to his dad? Or is there some spot here where he can be one place and still remain truthful to both his parents? And that spot, of course, is right on the corner of Macdonald and George. At that one coordinate, or that one intersection, both the statements Yaman is on Macdonald and the other statement Yaman is on George Street, both of them are true. Given the information provided in the following problems, model each mathematical form as a system of linear equations. You do not need to solve the system to find a solution. So we don't have to find out exactly what x and y are. We just need to write an equation that represents two statements. So the first statement is the sum of two numbers is 24, and the second statement is the same two numbers multiplied together to be 143. So we'll let x represent the first value, the first number, and y will be the value of the second number. So the statement, the sum of two numbers is 24, well, the sum means to add. So we could say x plus y equals 24. The second statement says the product of the same two numbers is 143. Well, product means to multiply, and it's the same two numbers, so we're talking x and y. So we could say x times y equals 143. So once again, they're not asking us to figure out what x and y are just yet. We just want to be able to write two equations that represent those two statements. And later on, when we start talking about factoring, this kind of skill will become very important. The SPSS Student Council held a raffle and sold 480 tickets. Students were charged $2 per ticket and teachers $5 per ticket. Total ticket sales were $1,560. Determine the number of teachers and the number of students who bought tickets. So we'll make our declarations. Let x represent the number of students who bought tickets, and let y represent the number of teachers who bought tickets. Now we're told that there were a total of 480 tickets sold. So we can say that x plus y equals 480. Now we were told that students were charged $2 per ticket and teachers $5 per ticket, and that the total sales was $1,560. So if X represents the number of student tickets sold, and each student ticket costs $2, we could say 2X represents how many student tickets. Sorry, let me rephrase that. 2X would represent the total value of all the student ticket sales. Y represents the number of teacher tickets sold, and each one of those tickets cost $5. So 5Y would represent the cost of all of the teacher tickets. And we know that those two numbers put together make a total of 1,560. So we can say 2X plus 5Y equals 1,560. And that's all our question is asking. We're not asked to figure out just yet what the number of student tickets sold or the number of teacher tickets sold. We're just asked to write the equation, which we've done here. However, if we wanted to go a little bit further, we could graph these two equations. So we've got this equation x plus y equals 480. So if we put that on the graph, it would create a line like this. X plus y equals 480. And this means that any of these combination of tickets, teacher and student ticket sales, would equal 480. Now it could be that no students bought any tickets, but 480 teachers bought a ticket. So that's one possible scenario. Not a very likely one, but it would still satisfy this equation. 0 plus 480 does indeed equal 480. So this could have been a possibility. Or maybe 80 students bought tickets and 400 teachers bought tickets. Once again, it satisfies the equation, so this point right here is a possibility. Another possibility is that 120 students bought tickets and 360 teachers bought tickets. Or 200 students and 280 teachers bought tickets. Or perhaps 280 students and 200 teachers bought tickets. Or maybe 400 students and 80 teachers bought tickets. Or maybe 480 students and 0 teachers, cheapskate teachers, bought tickets. Any one of these points here represents a possibility, as well as a whole bunch of other possibilities anywhere along this line. We don't know which one of these possibilities was the actual occurrence. We don't have enough information to figure that out. Now we're also told that the number of students times $2 plus the number of teachers times $5 equals a total sales of 1,560. And we could graph this particular line, and it would look like this. So perhaps 0 students bought tickets at a rate of $2, and 200, let's see, that looks like about 300, I'll go back here, and 312 teachers bought tickets. Or maybe 80 students bought tickets and 280 teachers bought tickets. or perhaps this scenario, 180 students and 240 teachers. Again, any of these are valid possibilities according to this equation right here. But we don't have enough information to know exactly which one. So, repeating ourselves, x plus y equals 480. Any of these points along the green line represent possibilities for x plus y equals 480. Any of these points along the red line represent possibilities for the sale of tickets. But only one point satisfies this possibility and this one. The only way that this can be true and this can be true is that 280 students bought tickets and 200 teachers bought tickets. And you can take these values, 280, 200, and plug them back into our equations. 280 plus 200 equals 480. These two values satisfy this equation. And if we took $2 times 280 plus $5 times 200, it satisfies this equation. So at this point right here, both of these can be true. And so now we have an answer. 280 student tickets were sold and 200 teacher tickets were sold. Again, we're not asked to figure this out, but we will be in a day or so. In a hockey arena, rink level seats cost 3 times as much as seats in the upper level. If 5 seats at rink level cost $112 more than 8 seats in the upper level, find the cost of a seat at rink level. Well, let's do our declarations first. Let U represent the cost of an upper level seat, and let R represent the cost of a rink level seat. Now, generally speaking, the closer you are to the action, be it a sporting event or a concert, the more expensive the tickets are, and so it is in this case. Rink level seats cost 3 times as much as seats in the upper level. So we can represent that with an equation. R equals 3U. The cost of 1 rink level seat is the same as 3 upper level seats. Now we're told that 5 seats at rink level cost $112 more than 8 seats in the upper level. So we can say that those 5 seats at rink level are 5R, and 112 plus 8U is $112 more than the 8 upper level. Okay, so there's our equation to represent that statement. And once again, we aren't asked to figure out what exactly R and U are yet, but if we graph them, we could see where those two graphs intersected, and the intersection point would represent what the R and the U value are, but that's another day. Jared has $3.85 in dimes and quarters. There are 25 coins in all. How many of each type of coin does he have? Let's do our declarations first. We'll say that the dimes, or D, represents the value of the number of dimes, and Q represents the value of the number of quarters. So we know that there's 25 coins in all, So we could say that D plus Q equals 25. D is the number of dimes, Q is the number of quarters. Those two values or variables added together make for a total of 25 coins. Now we're told that the value of the dimes and the quarters together add up to $3.85. So we could say that 0.10 for 10 cents times the number of dimes plus 0.25, the value of quarters, times Q equals a total of $3.85. Now, dealing with decimals is a little bit tricky. You may want to multiply this equation by 100 on both sides to give us an easier number, so we'd get something like 10D plus 25Q equals 385. That might save us the hassle of having to deal with decimals. But at any rate, these are the two equations that represent these two statements. The total cost of concert tickets for 2 adults and 4 students is $120. If student tickets are $15 each, determine the price of an adult ticket. So we'll start with our declarations. We can say S represents the cost of a student ticket, and A represents the cost of an adult ticket. Now we're told that the student tickets are $15 each. So we can say that S equals 15. We're also told that the total cost of concert tickets for 2 adults and 4 students is $120. So we have 2 adults buying adult tickets, that's 2A, and we have 4 students buying student tickets, that's 4S, equals a total cost of $120. Now we're given, this is basically our answer. We've modeled the equation, and we could stop right here, but let's take it a little bit further. Because we're told that S is equal to 15, we could take that 15 and sub it in to the other equation. We could say 2A equals 4 times 15 equals 120. Which should give us 2A equals 120 minus 60. And eventually, we come up with a value of 30 for the adult tickets. Therefore, the cost of an adult ticket is $30. Yamir weighs 30 kilograms more than twice his brother's weight. If the sum of their weights is 120 kilograms, how much does each brother weigh? We'll start with our declarations. B can represent the younger brother's weight, and Y can represent Yamir's weight. So we're told that Yamir weighs 30 kilograms more than twice his brother's weight. So Y will equal 2 times his brother's weight plus 30. Now we're also told that the sum of their weights is 120 kilograms. Sum means to add, so we could say that X plus Y, actually it should be B plus Y equals 120. So that basically gives us our equations. We're done the questions, but again, let's take it a little bit further. We could take that value of Y equals 2x plus 30, and we could substitute into this equation of x plus y. So y and 2x plus 30 is the same thing. So why not take that 2x plus 30 and substitute it in here for y? This way, we only have one x variable to worry about, and we can solve for x. Gives us 3x equals 120 minus 30, and we eventually end up with a value of 30 for x, or this represents the younger brother's weight. Now we can take that 30 and sub it back into one of the equations. So 30 plus y equals 120, and now we can solve for y. We end up with a value of 90. So the younger brother weighs 30, and Yamir weighs 90. There are twice as many quarters in a jar as there are nickels. The total value of the coins is $2.20. How many of each coin are in the jar? Well, we'll write our declarations first. N for nickels, Q for quarters. And we're told that there are twice as many quarters in a jar as there are nickels. So for every quarter, there are 2 nickels. The total value of the coins is $2.20. So we can say that 0.05 N, 5 cents times the number of nickels, plus 0.25 Q, 25 cents times the number of quarters, equals $2.20. Now, we could eliminate the need for decimals by multiplying that second equation by 100. And if we do that, we get a simpler equation of 5n plus 25q equals 220. 5n plus 25 times 2n. So what we did here is we took this q and we substituted its value into this equation. Okay, q is equal to 2n. Therefore, 25q is equal to 25 times 2n. And what we've done here is we've gotten rid of our q's, and now we're just dealing with n's. And once we have just one variable, we can solve for that variable. 5n plus 50n equals 220. 55n equals 220. N equals 4. Now, once we have a value for n, we can substitute it back into the equation to figure out what q is. So we could say that q equals 2n. We take that n value and we substitute a 4 in there for it. Q equals 2 times 4. Q has a value of 8. So now we have a value for n and a value for q. So we could have a closing statement that says there are 4 nickels and 8 quarters. Three times as many robins as cardinals visited a bird feeder. If a total of 20 robins and cardinals visited the feeder, how many robins were there? Well, we'll make our declarations first. R representing the robins, C representing the cardinals. 3 times as many robins as cardinals visited a bird feeder. So we could say that R equals 3C. And then we're told a total of 20 robins and cardinals visited the feeder. So we could say that R plus C equals 20. Let's give these equations numbers. We'll call this r equals 3c, equation 1, and r plus c equals 20, equation 2. In equation 2, r plus c equals 20. We're going to replace the value of r from equation 1 that states r equals 3c. So instead of saying r plus c equals 20, we're going to say 3c plus c equals 20, which gives us 4c equals 20, gives us a value of 5 for c. Now we can take that value of 5 and we can plug it back into one of the equations. So let's plug it back into equation 1. We know what c is. We'll take that value of c and we'll plug it back in to equation 1 and we'll find out what the value of r is. We do that. R becomes 3 times 5. R equals 15. So we can say there are 15 robins and 5 cardinals at the bird feeder.